Right, so in this one we're going to look at using fractions to determine our probability. Now, this is a little bit weird for the first couple of slides, so bear with me. I'm just trying to show you where this comes from so you can see it happening. By the time you get to slide 3, hopefully you've understood where it comes from, but if you haven't been, slide 3 is going to tell you exactly what you need to know about using fractions to find probability. So, for this first one, if I wanted to find the probability of rolling a 1 on my green dice and a 1 on my yellow dice, and yes, I'm using the same example that I've done in a couple of videos, so if you're confused, go back a couple to see where this chart came from. Go to my first one using tables and trees. So what I want is I want a 1 on my green dice and a 1 on my yellow dice. So the only way to do that is obviously this one right here. But what I'm going to show you is I want to remind you way back when we started multiplying fractions together, how we used our fraction diagrams. So remember, what I did was I took my whole rectangle, so I'm going to pretend this part that I'm outlining here, this is my whole rectangle, and look at that, I've split it into 1, 2, 3, 4, 5, and 6 equal sections, right? 1, 2, 3, 4, 5, 6 equal sections, and only one of those sections gives me that value that I want of 1 for yellow. So I'm going to color in that section red. Remember when we did this with our fraction diagrams? We would color in that whole strip, right? So all of these ones that I just colored in, and I mean, I guess you can't really see the table anymore, but all of those ones I just colored in would give me a 1 on my yellow dice, which is good because that's my favorable outcome, is a 1 on the yellow dice. And now I'm going to do the same thing on the green dice. On the green dice, I want a 1. So I've taken my rows, which are my green dice, and look, I've split into 1, 2, 3, 4, 5, 6 outcomes, right? Because I can get 1, 2, 3, 4, 5, or 6. But the only outcome I want is that green 1. And so that's all of these in this section here. Now, when I color this in, all those blue ones give me a 1 that is green. The only one that is colored in both colors is this one right here. So if we think about what I was just doing there using my fraction diagram, is I looked at the probability of getting a 1 on my green dice, that's my blue color, sorry. There is one way of doing it out of 6 possibilities, and that's what I showed in my fraction diagram, right? Here's my whole rectangle, and I split it into 1, 2, 3, 4, 5, 6 equal rows going across, and I colored one of them in blue. And then I had my yellow one. And there was one way of getting a yellow one out of 6 possible outcomes. And if you look at my fraction diagram, I had 1, 2, 3, 4, 5, 6 columns, 6 sections, and one of them is colored in red. Well, really, if you look at this, and I was to multiply those two fractions together, which is exactly what this is if I'm thinking of it as a fraction diagram, I would get 1 out of 36. Now we knew it was going to be 1 out of 36, right? There was only the one outcome that had both of those things and 36 total outcomes. But look at that. If I think of it as a fraction diagram, I can multiply my fractions to get the same probability. I'll do one that's a little bit more complex. So looking at this one here, I've got what is the probability of getting a 1 or a 2 that is green. Okay, well, if we think again, this section here is my fraction rectangle, the whole rectangle representing one whole. I've split it into 6 rows going down the side. 2 things will satisfy my expression. I need a green 1 or a green 2, so that's all of these numbers here going across, right? So here's my blue fraction strips. I would be coloring in 2 out of 6, right? So my first portion is 2 out of 6. For the yellow one, it says I need to get 1 or 2 or 3. So again, I've split into 6 columns. right? 6 total outcomes for my yellow die. 3 of them are going to work. This one here works, where I get a yellow 1 or a yellow 2 or a yellow 3. So I would color in these rows as well. And if you think about what I've just done in my fraction diagram, is I have colored in, I've colored in 3 pieces out of a total number of 6 possible pieces being split into columns like this. Now, if I'm looking at this here, my overlap is 1, 2, 3, 4, 5, 6 sections are colored both colors. So I'm going to get 6 out of, and my total is 36. That means there are 6 ways of getting a green 1 or 2, and at the same time rolling a yellow 1 or 2 or 3. That means I also have a 1 in 6 chance. And really, if you look, 2 times 3 gives me 6. 6 times 6 gives me 36. So using the table shows me how I can use my fraction diagrams, which I know you guys love so much, to find probability. Okay, so let's clear this up. To find probability using fractions, and this works only when you have independent events. So let's be very clear about that. We need independent events in order to be able to do this. That means that one event has no impact on the possible outcomes of the other. Okay? So what I'm going to do is I'm going to find the probability of each independent event separately, and then I'm going to multiply the probabilities together. Kind of just like we did with outcomes, right? I found the total number of outcomes for each event, and then I multiply all the possible outcomes together to get my total. Well, now I'm finding the probability of each event separately, and then I multiply all the probabilities together. It's so simple. And now I don't need to draw trees or tables every time. Oh my goodness, you should be crying tears of joy so you can stop drawing those tables and trees. So let's look at this here. What is the probability of flipping heads on a coin and rolling a 4 on a 6-sided die? So I'm going to look at my 2 different things. So I'm going to flip a coin, and I'm going to roll a 6-sided die. Okay, so when I'm flipping my coin, I want to get heads on the coin. What's the chance of getting a heads? Well, I've got 2 total outcomes, and one of those outcomes is heads. So I've got a 1 in 2 chance of flipping heads. For my die, when I roll a 6-sided die, I have 6 possible numbers I could get. 1, 2, 3, 4, 5, and 6. But only one of those numbers is a 4. So I have a 1 in 6 chance of getting a 4. I'm going to multiply them together. 1 times 1 gives me 1. 2 times 6 gives me 12. The chance of me flipping a heads and rolling a 4 at the same time is 1 out of 12. And I simply looked at my coin separately, my die roll separately, and I multiply the 2 probabilities together. Oh my goodness, that's so much easier. It's way better than drawing a tree or trying to put it into a table. Let's look at this one. What is the probability of spinning red and rolling an even number on a 6-sided die? So I've put the spinner on the side for you so that we can look at what it is we're doing. So what is the probability of spinning red? Okay, well, when I'm looking at my sections here, I've got a blue section, a purple section, a green section, and a red section. There are 4 sections, and it looks like they are all pretty equal. So I'm going to assume that they are all equal in size, but only one of those sections is red. So I have 4 possibilities, but only one of them is favorable, giving me that 4, or giving me that red that I want. Okay? When I look at my die, the die roll has 6 possibilities because it's a 6-sided die, but I want to roll an even number. Well, that means I could get a 2 or a 4 or a 6. Any of those 3 numbers is fine. So I now have 3 favorable outcomes. So I'm going to multiply these 2 fractions together. Now, I could do some cross-reducing, right, because the x is pointing across from one another, but I also have some just reducing I can do right here. 3 and 6 is the same thing as 1/2. So I could reduce that before I multiply. Looking at my numerators, 1 times 1 gives me 1, and 4 times 2 gives me 8 in the denominator. So the chance of me both spinning a red and rolling an even number on a 6-sided die is 1 in 8. Now if you don't believe me, go ahead and draw the table. But it's going to take way more work than just multiplying the fractions together. Okay, let's do one more. Now remember I said if you're doing more than 2 events, now you have to draw a tree. And that's a real pain. Those trees can get crazy. So this one I'm going to find probability of flipping a coin 5 times in a row. But I want to get tails every single time. Okay, well, I'm going to flip the coin the first time, and I'm going to flip the coin the second time, and the third time, and the fourth time, and the fifth time. And every single time I want to get tails. Okay, well, I've got a 1 in 2 chance of getting tails the first time, and a 1 in 2 chance of getting tails the second time, and a 1 in 2 chance on the third, and the fourth, and the fifth. And the probability of me getting tails 5 times in a row is simply multiplying all 5 of those fractions together. Multiplying 5 ones together still gives me 1. But 2 times 2 times 2 is 4, times another 2 is 8, times 2 again is 16, times 2 again is 32. The chance of me flipping tails 5 times in a row is 1 out of 32. Now if I'm trying to do that in a tree, that means I've just had to draw 32 different branches. Oh, what a pain. But using fractions to help me find probability, way faster. Okay? So your big takeaway for today is you can find the probability of each independent event, then you can multiply the probabilities together. And that is how we use fractions to help us determine probability.